All right, so this part we are going to focus on the theory itself, or the algorithm itself about K-means. And we hope that we are able to do that from scratch. And there are some settings in the handout. For example, what is the input and what is the output? What does the notation mean? But you can just check out the handout. And here I will just explain what's going on with each step. Okay. So basically, you will have a data set called X, right? And then you have to input the K, and it will output the label Y. And if you want, you can output the centers. Okay, so that's our goal. With the given data set and given K, I want to generate what is the label and what are the centers. Okay, so now let's look at each of the step one by one. Let me see if I can copy that again to the next page. Okay, so let's give a brief overview first. This algorithm composed of 4 steps. The first step is the initial step. You want to have a basic setup. And essentially, the first step is just randomly pick some centers. So anyhow, I will give you more explanation later, but the first step is just a very basic setup. Now, the second step and the third step are the essential idea here, and we will say that more. But after that, you will see number 4 is a set repeat steps 2 and step 3, just a 2, 3, 2, 3, 2, 3. Keep iterating that until you are satisfied with the result. And one way you say you are satisfied is the label is no more changing, then you will stop. Okay, 2 and 3 will keep generating new labels, and then until the label is not changing at all, then you will stop. So now let's go with that. I will explain in detail for each part. Okay, so it says that initialize the collection of the centers. So basically here you have a lot of different ways to do that. Okay, so essentially you can do whatever you want. This step is basically saying just pick K points as your initial centers, whatever the center it is. Okay, you can just pick any points you like, or you can pick some points in the data set, or just specify some of the point to be the center. Okay, so in terms of the picture, maybe you have some data like this. Okay, I'm going to use this several times. This is our X, and after the first step, you can just pick some of the points. You can pick some of the points as your center. So maybe I want to say this is mu1, and this is mu2. This is mu3. Okay, or let's make it more interesting. Okay, you don't really know where should put the mu1, mu2, mu3, and you just randomly pick some. And like what I say, if you want, you can also pick some points outside, say this is mu1. But usually, the convention is just randomly pick some points in your data points. You have say 9 points, then just randomly pick 3 of them as the mu1, mu2, mu3. Easy enough, right? Okay, so that's the first step, and then you will record that into your center. That's the current center. Now let's look at the second step. Okay, while I'm copying that, you can see that it says that try to label each sample by j if mu j is the closest center to xi. Okay, it is just a lot of notation, and it says that for each x, just label it by the index. Okay, so I'm going to copy that several times. Bear with me. So it will be easy just to think of this one. Okay, this is essentially what you just did in the activity. You have 9 points. Each point you are going to label it by the closest center. So this one, the closest one is this one. So it is going to be labeled by 1. Okay, given with some centers, you are going to label each of them by the index of the closest center. So all these 3 points, I think no doubt that it is the closest one. Okay, now you can apply some of the knowledge that we know before, how to distinguish which one is closer to mu1 or mu2. You can draw the perpendicular bisector here. Maybe it is around here, right? And for here, you can also draw another bisector here. So you will see like a partition of the space, realizing that for this point, it is not so close to mu2. It is closer to mu1, right? And also, sorry, I got stuck. But meanwhile, because it is let's see, it is also closer to mu3, right? So if you draw this line a little bit longer, this point says that it is closer to, oh, okay, let me do one more. Okay, so you will have 3 lines between every pair of them. But anyway, you can just try to do it by yourself, and you are able to see that for this point, it is, if you compare mu1 and mu3, it is closer to mu3, right? Because of this line. But if you compare mu1 and mu2, it is closer to mu1. And if you compare mu1 and mu2 and mu3, it is closer to mu3. So this is closer to 3. I'm making it overcomplicated, but all these points are closer to 3, but all these 2 points are closer to 2. Okay? So up to here, you are able to label the points with the centers. Now let's move on to the third step. It's a bit tiring to copy all these things. But while I'm copying, you will see that it says that call the points with the label J as group J. Now you have group 1, group 2, and group 3. For each group, update its center, and the new center is the center of the group. I think it is easier to put the 2 steps together because we are going to repeat 2 steps all the times. Okay, now this is the result from the previous step, right? So let me put it here. while taking out some of the not necessary things. Okay, now at this point, you will see that all the points are labeled. And imagine that you just forget about the previous centers. The centers are gone. Okay, you use the center to do the label, but after that, just forget about that. Now all you have is the labels. And it says that call the points with label J as group J. So this is the group 1, this is group 2, group 3. Now you have 3 groups. Use each of the group to determine a new center. Now 1, 2, 3, right? And the center is supposed to be here, and call that as mu1. This is the new mu1, and 2, 2. The group 2 has the new center here, mu2. And for all the 4 points here, it is group 3. The center is likely to be here, mu3. Okay, so what you did is with the label, you can determine the center again. Okay, so now you can see what it means by number 4. Step number 4 says that you are going to iterate over step 2, step 3, and step 2 and step 3. You are going to repeat these things several times. At the very beginning, the centers are just given randomly. But you see, once after just one iteration, you see the center is sort of going to each group, right? This is the center of this group, and this is the center of this group. This is the center of this group. And it is pushing each other, and because this group is now too big, and this mu2 will try to steal this point to belong its mu2 is trying to steal this point to be its neighbor, because you see the next step, this point is going to be labeled by mu2 instead of mu3 because it is closer to here. So in the next step, this one will become group number 2. This will be group number 3, group number 1. So once you iterate over it several times, it will stabilize into a label, and it will be done in the end. Okay, so that's the big idea of the K-means. Essentially, you just initialize it, and then repeat 2, 3, 2, 3, 2, 3, and then eventually you will get stabilized and find the centers and the labels.